Electrical test equipment. In this presentation, you will explore common types of test equipment used on vehicles. Introduction. A digital multimeter, or DMM, is a tool that can be used to investigate the electrical circuits on a vehicle. A typical DMM is capable of measuring electrical quantities of voltage, current, and resistance. It can also test for continuity. Digital multimeter. A typical DMM has these features: a digital display, a range selector, connections for 2 test leads, measuring DC voltage. This DMM is being set up to measure DC voltage. The black test lead is connected to the socket labeled COM. The red test lead is connected to the socket labeled V. The DMM is switched on. The range selector is set to a suitable DC voltage range. The range setting of 20 volts is appropriate for measuring 12 volts across a lamp. Testing for continuity. This DMM is being set up to test for continuity. The black test lead is connected to the socket labeled COM. The red test lead is connected to the socket labeled ohms. The DMM is switched on. The range selector is set to the continuity range setting. The symbol for continuity range is usually a loudspeaker or a musical note. Testing the continuity of a component. How to test the continuity of a fuse, a switch, or wire. Remove power from the circuit and isolate the component or wire. Connect the test lead probes across the component or wire. If continuity is detected, a beeper will sound and the value on the DMM display will be close to 0. If continuity is not detected, the display will show an out-of-range indication. Question 1. Which statement is true? If continuity is detected, the DMM will display an out-of-range indication. The symbol for the DC voltage range is usually a loudspeaker or a musical note. Continuity will not exist if a fuse has blown. A setting of 200 volts is appropriate for measuring 12-volt electrical systems. Continuity will not exist if a fuse has blown. Measuring resistance. This DMM is being set up to measure resistance. The black test lead is connected to the COM socket. The red test lead is connected to the ohm socket. The DMM is switched on. The range selector is set to a suitable resistance range. A setting of 200 ohms is appropriate to measure the resistance of a lamp. Measuring the resistance of a lamp. How to measure the resistance of a lamp. Remove power from the circuit and isolate the lamp from other components. Connect the DMM probes across the lamp. The display will show the measured resistance. Question 2. Which resistance range is suitable for measuring the resistance of a lamp? 200 ohms, 2 kiloohms, 20 kiloohms, 200 kiloohms. The 200 ohms range is suitable for measuring lamp resistance. Measuring DC current. This DMM is being set up to measure DC current. The black test lead is connected to the COM socket. The red test lead is connected to the socket labeled A. The DMM is switched on. The range selector is set to a suitable DC current range. Always select a higher range than the expected current reading. How to measure the current flowing in a circuit. Break the circuit and connect the red probe on the side of the circuit that goes to the positive battery terminal. Connect the black probe to the other side. Adjust the current range setting to obtain an accurate reading. The measured current will be shown on the DMM display. Current clamp meters. A current clamp meter removes the need to break a circuit when measuring current. The jaws of the meter are clamped to a cable. The meter uses a sensing device known as a Hall effect sensor to detect the amount of current flowing through the cable. Oscilloscopes. An oscilloscope displays and measures electrical signals. The screen is divided into squares, typically of these divisions: 10 divisions on the horizontal or x-axis, 8 divisions on the vertical or y-axis. Voltage and time period measurements are taken by observing how many divisions the waveform covers on each axis. Time period. The time period represented by each x-axis division is set using the time-based controls. One cycle of this waveform covers 5 divisions on the x-axis. If the time base is set to 20 milliseconds per division, the time period can be worked out. The time period is the time taken to draw one cycle of the wave over 5 divisions. Amplitude. The value of each y-axis division is set by the Y-amplifier controls. The height of this waveform covers 6 y-axis divisions. If the Y-amplifier is set to 5 volts per division, the amplitude can be worked out. The amplitude of the wave is the peak-to-peak value of the voltage over 6 divisions. Oscilloscope probes. An oscilloscope probe connects the oscilloscope to a signal source. Some probes include circuitry so that the measured signal is attenuated by a factor of 10. This feature extends the range of signals that the oscilloscope can measure. Dedicated diagnostic equipment. Generic or manufacturer-specific diagnostic equipment makes the job of fault finding much easier. These pieces of equipment are commonly called scan tools. A scan tool displays live data while the vehicle's engine is running. It shows possible causes of faults. Question 3. This waveform is displayed by an oscilloscope with a Y-amplifier volts per division control set to 50 volts per division. What is the peak-to-peak amplitude? 50 volts, 100 volts, 200 volts, 400 volts. 200 volts. Count the number of vertical divisions between the positive and negative peaks and multiply by the time per division. Summary. In this presentation, you have explored common types of test equipment used on vehicles.